Okay, so in this video we're going to be looking at interpreting graphs of linear functions. That is our title for today. But before we look at this problem, I just wanted to go back and look at this graph. So we were asked to identify the independent and dependent variables. So remember, we want to associate the independent variable with the x-axis, right? So independent variable means the x-axis, I want to associate that with x, the values of x, which is the domain. Okay, so I want to kind of relate all those things in my head. So the independent variable in this case is time. Independent time. And the dependent variable then is volume. And that's going to be the case always. The independent variable is going to be on the horizontal axis and the dependent variable on the vertical axis. So you want to keep that in mind when you are given, for example, a data table like this to graph. We would have up here the independent variable, the dependent variable. In this area, I have my range, and here the domain. And when I create a graph of this data table, for example, in a different question where I'm creating a graph, then I want to put whatever this concept is here, down here. That's where that goes. And the dependent variable goes there. So if you're asked to create a graph, you want to make sure that the first column, that first concept, is your label down here, and the second one is there. Okay, so anyway, that's for another assignment another day, but that's the idea with that. All right, next question says, determine the rate of change and describe what it represents. So now I'm going to determine the rate of change from a graph. And to do that, I want to draw in a triangle that goes from one point to another point on that graph. And I'm just going to pick the two extremes and draw in this triangle here. And you can see that my change in x, the horizontal change, is 120 minutes. And now you can see from here I'm going downward. So my change in y is actually negative because I went down, and I went down 9,000 liters, and it's actually negative. So over here, when I'm calculating the rate of change, that's going to be equal to the change in y over the change in x, the rise over the run. And you can see that my rise is actually negative because this graph is going downwards. So that's negative 9,000 over 120. And the units are liters per minute. So if I do liters per minute, if I do that division, I'm going to get negative 75 liters per minute. What does that mean? Well, this graph is about the emptying of a water tank. So that tells me each minute 75 liters are emptied out from the tank. All right, so here we have a very similar graph. Also, you can see the triangle has been drawn on for us right here, and this is about the descent of an airplane. Labeled, we have the y-intercept and the x-intercept. And so the y-intercept is the point of intersection of the graph, shown in kind of that pink line there. Is it pink? With the y-axis. So that's this point right here. And it is at 1,800 meters. And the x-intercept is down here at 12 minutes. And so now, what do they represent in this context? Well, in this context, at time 0, the initial elevation is 1,800 meters. So at time 0, the elevation is 1,800 meters. So that means that's the height of the elevation of the airplane before it begins its descent. And then down here at an elevation of 0, the time is 12 minutes. So that means it took 12 minutes to descend. So it's not just identifying what the number is and reading it off the graph, but also thinking about what does it represent in a given context. So here I've got another graph for us to look at, and this says profit from the whodunit mystery theater. And again, the X and Y intercepts are labeled. So you can see over here the Y intercept is at negative $500. And the X intercept is right here at 40. So this is the Y intercept, and the X intercept is at 40 what? Tickets. So think about what could they mean in this context. What does the y-intercept mean in this graph that is about the profit of this theater? Y is, when the number of tickets sold is 0, y is the profit negative 500. So x is 0, negative 500. Why is that? Well, this is probably the initial cost to set up the theater, to set up for this show. Maybe they had to buy costumes, they had to pay actors, and so on. So they start with a deficit of $500. The x-intercept is at 40. And if I think about that point, when I've sold 40 tickets, the profit is 0. So this is really telling us when we break even, the break-even point. So if I'm running this theater, I want to sell at least 40 tickets so that I don't lose any money. And then after that, you can see the profit is now into positive numbers. Okay. Here's another one. This is about fuel consumption of a Ford Escape hybrid SUV with a full tank of gas. So on the x-axis, I have distance, the distance traveled. And on the y-axis, I have volume of gas in the tank. So maybe this would be a good point for you to pause, determine the coordinates of the x and y intercepts, tell me what they mean in this context, and then also try and state the domain and range. Okay, so what does all this mean? The x and y intercepts. So the x-intercept is down here where the line crosses the x-axis, and that's at 800. So the coordinates would be 800, 0. The y-intercept, on the other hand, is up here at 0, 60. And so what does this 800 and this 0 mean? Well, it means 800 kilometers, and the y value here is the volume. So after going 800 kilometers, the volume of gas is 0. What does that mean? It means the tank's empty. So on a full tank, assuming that 60 is a full tank, I can go 800 kilometers. And the y-intercept, so this here was about the x, the y-intercept at 60 liters is the starting volume of gas in the tank before we started measuring distance. So at distance 0, we leave the gas station, we have 60 liters. Okay, and now the domain and range. So a bit of a throwback to an earlier lesson on domain and range. I'm just going to clear this up so I can see what's going on. So remember, domain tells us the x values. Where is the graph in terms of x? Well, it looks like it starts here and it ends there. So x is between 0 and 800. And x is an element of the real numbers because this is a smooth line or curve. Well, it's a line in this case, but that's my domain. So that's the domain. And the range is now related to the y values. Where does this graph exist in terms of y? And I can see it starts at 0 down here and it ends at 60. I know I'm going backwards there, but for the range, we want to record the lower number here and then the higher one there. So 0 to 60, y is an element of the real numbers, and there's my range. Okay, so here's one for you to try on your own and see if you can use this graph and the information here to answer these questions. So this would be a good point to pause it and try that. Okay, so now we'll go through this together and see if you were able to come up with the right answers for all of these questions. And this is a really good kind of quiz or test type question to make sure if you've understood all the ideas in the chapter up till now. So domain is the x values. I'm looking at the x-axis. And this graph goes from 0 to 200. So I'm going to record that. X is between 0 and 200, and x is an element of real numbers. Instead of using an x, I could use maybe a d for distance as well. And now the range is the volume. This is the y values. And it goes between 0 and 8. So 0, y, 8, and y is an element of the real numbers as well. So there's my domain, there's my range. I hope you got those. The intercepts. So the y-intercept is up here at 8. 0, 8 is the coordinates for that. What does that represent? That represents the tank in this scooter. So there were 8 liters of gas when we started out. And the x-intercept is down here at 200. So 200, 0. This 0 means 0 liters in the tank. So I can go 200 kilometers can be driven or ridden or whatever on this scooter with 8 liters of gas. And now the equation to model this. So again, if I'm going to, well, I guess this is one of the first times we're seeing this, but if I'm going to write out an equation, in general, I write out that the dependent variable equals the rate of change times, rate of change time. Okay, so I wanted to show you how to write out an equation for a situation like this. So in general, and this is what you want to write down so you remember how to do this. In general, I write that the dependent variable, which in this case is volume, equals the rate of change. I'll write that out, rate of change, which over here I'd have to calculate that. So I can see again that I'm going downward 8. If I draw out this triangle, so my rate of change is the change in y over the change in x. So hopefully you remember that from before. And you can see here my change in y is -8 because I went down 8 and then to the right, positive direction, 200. So that's my rate of change. And I want to reduce that. So I'm going to call it -0.04. And that's my rate of change for this, times the independent variable, What's the independent variable? Distance. So v equals negative 0.04 times d for distance, and then at the end, plus the initial value. And by initial value, I mean, where did the graph start off? So if I look over here and clean up some of this mess, you can see that I started at 8. So that is my initial value, plus 8. So this equation I can use to calculate what is the volume of gas after a certain distance. So, for example, let's say, what's the volume when the distance is equal to 100? So I've gone 100 kilometers. How much is left in the tank? V equals negative 0.04. And now I'm replacing distance with what distance is, 100 plus 8. So this is negative 4 plus 8, which is 4. And you can see that value on here. If I go from 100 up to my line and go over, yep, 4. That is the volume of gas after I've gone 100 kilometers. So that's how you create an equation given a graph. Dependent variable equals the rate of change, and we know how to calculate that either from a graph like this or from a table of values, times the independent variable, which is like our x, plus the initial value where the graph started.